right, guys. So I hope many of you have joined, and thank you. It's an honor, of course. So you have joined basically. So let's begin with this. So my name is Gaurav, and uh, so this is a topic we have using RStudio to analyze basic statistics through programming language. So it's RStudio. Actually, the software is RStudio, one of the software where we just analyze statistics and we apply basic commands in that so that we can just work on little bit problems and work on basic statistics like mean, median, mode, and different things. We'll work on this in session basically. So step by step. So I think the first step is okay. So basic statistics. So in this tutorial, so you all are teachers, of course, and maybe I hope that many of you may be teaching statistics, or many of you maybe not teaching statistics, but still, I hope that you have basic knowledge of stats and the basic things about stats. So right now here, so you as a teacher, the purpose is that to make you aware. Maybe you heard about before RStudio is a software to analyze statistics. So we're using a technology here that is RStudio to analyze basic statistics through programming language. So we have calculators, right, to solve statistics, big data problems to find out the mean, median, mode, deviations, doing standard deviations and doing different tests, hypothetical tests and everything we do in statistics. Then we have different kind of other softwares, but why especially RStudio we have why are you using RStudio when we have calculators, then we have Excel also. Maybe you have tried in Excel to work on basic statistics. So why RStudio and why going through programming language? What the purpose of going through programming language when we have calculators, Excel, and different things? So, well, during this session, we will keep on exploring these things. What are the importance of RStudio and how it is so useful, it's so handy, and it is easy or not. So that we will explore during the session. So just moving on. So who am I? So, yes, so basically I'm from India and I completed my graduation in the year 2012 and I did my BTech. So, in electronics and communication, there we had major in mathematics. So, I was basically more and more involved in mathematics during my graduation. So, I was not in so much into electronics and communication part, but it was more about mathematics because from childhood only I had keen interest in doing mathematics and doing the stuffs here. And second thing is after my graduation, I just worked with the top edtech companies. So the world is now completely online. The completely edtech companies are there. Different companies are exploring day by day. And I'm also as a teacher. So I'm basically a math teacher, and I'm online teaching and creating videos for different things and doing stuff right now for statistics. So I was also involved with some edtech companies and currently also involved in a few edtech companies to do the different projects and to work on mathematics. And right now and presently, I'm exploring more into statistics because I'm working on different softwares in statistics. Then about my experience, I especially worked with Indian curriculum and now international curriculum, IBDP curriculum. I was so much involved in that, and the students were quite happy with my teaching, and they have been placed in good universities towards the teaching career. So yes, so why statistics? How I got into statistics basically. So during my graduation, I was learn basic about statistics like normal distribution. We have different types of noises and quotient distributions we have. So different kind of statistics was involved actually. But during my teaching career, I got some opportunities to teach some students who want to learn statistics more and more and want to score good in statistics. So thereby, as per my experience, I got in touch with US students also and Canadian students also. Especially, I was working from past 3 to 4 years with the US students, and thereby I got keen interest to teach statistics using different tools and technologies. Because what I observed during my teaching career with US students, especially, so they come up with different kind of problems. They come up with different kind of statistics problems using different tools. Like one of right now we're discussing is RStudio. Then Excel is there, Stata is there, IBM SPSS is there. But different kind of tools they come up with. So that's how in the past 3 to 4 years I'm keen on exploring different technologies and tools so as to work on statistics and to work on different students' projects and problems and assignments, what they're coming up to. And I enjoy doing it because they come up with different problems, and I keep on helping them to solve them in different ways using different tools and technologies. Yes, right now, so basically right now, in today time, I'm working on preparing some videos for different textbooks, for including statistics and tools. I already keep on taking that. So statistics skills, I keep on exploring using different tools and softwares. So that is all about my basic background in education and experience. Okay, so now we're beginning with what is R and RStudio. So, if I just have a keen look here, let us read that. So, R is uh, basically a programming language we have. It is based on the S language actually. It is based on S language, and the interface what is using the S language that is known as R. So basically, more commonly it is known as R language, and it is a free open source software program for statistical analysis. So R is a kind of programming language. We have different languages like C, C++, Java, and other languages. Today, so many languages are there. I don't even know the names of the languages. So one of the languages R. So it is specially a software program for statistical analysis. The commands are there. The commands are really easy to implement that. For example, we have the command to find out the mean. We have the command to find out the median. We have the command to find out the z-score, to find out cumulative frequency, to do the histogram plots. So it is all based on the commands. We have for everything, there are different commands that we put in the R console, and accordingly, we get different outputs as well as different graphics. So this is we have all about the R. It's a language where you put the commands and then you work on the statistics and do statistics and find out the solve the statistical problems. Next is RStudio. So what is RStudio actually? RStudio is an environment. It's a development environment that is specially designed so that interfaces becoming really easy. We get an easy interface. We can put the commands, we can see the graphics, and we can do a lot of things. Right now, maybe you're feeling that you're not able to differentiate clearly between R and RStudio. But as we go along in with the tutorial, you will get to know the special difference between R and RStudio. So what I can do here, I can just give you a very simple visualization of the R. So this is the R actually looking quite complex and looking something like a programming language which you are not used to. Of course, math teachers are not used to programming language basically. So this is the console here we have, but I have made it really simple tutorial, very basic, so that you will feel it comfortable to apply the basic statistical commands and find it comfortable in the initial sessions and stay away from the complex part of R Studio. So this part you can see here, this is the R basically. A console, an interface where you put the commands. So as a command here we have, this one is a console here, R console. We put the commands and we get the output. For example, just do here 32 positive 12. I put enter here. I get the output as 44. That's a very basic command, 32 plus 12. I'm getting it as 44. We can do 43 negative 12. That's coming out to be 31. So that's a very basic instructions. The languages are, we're using it, putting it, and we're getting the output. So that is an R console. Now RStudio. RStudio is the environment where we will put the same commands, write the commands which we are putting here in the R console. The similar command, the same commands we'll put in the RStudio. Here we go. That is the RStudio. It's just an environment here. It's the same R console that is with this. There's the R console here. Same R console is built in the RStudio. There's the environment given to use the R programming language to input the commands. To input the commands, get the output, and you can visualize graphics. You can visualize more inputs, and you can do many more things in RStudio. So that is the a complete environment to work on our commands, put in the commands, get the outputs, and do your statistical analysis. So that's a basic difference between R and RStudio. So RStudio interface is organized so that the user can clearly view graphs. So RStudio is specially designed a user can clearly view graphs, data tables, then our code, whatever code we are putting basically in R to generate the output and output all at the same time. So RStudio is that environment for R. Here one note, you must install R before you can install RStudio. So sometimes what we do, we are new to R and we just install RStudio, but we forget to install R. So RStudio is just an environment. It uses the console R for working out. So therefore, we need to install first R, and after that, we can install RStudio. A little bit about downloading and installing, how to install R and RStudio. So you can see that I have put the basic links here. And if you just want to again see that, how to just do, you can clearly Google this out. So here we have download R. So we have download R 4.1.2, that's the latest version. This is for Windows here. Download R for Windows, and even you can download R for Mac accordingly. And you have other operating system for Linux. Just Google it out. Download R for Mac or download R for you have Linux. Just put it in and download it for R basically. Similarly, you can go for download RStudio. Just click on it, download RStudio IDE. Here we go. Download RStudio IDE. Choose your version, completely free. You can use it anytime, install it anytime, completely free. Click on download here. This is for download RStudio for Windows. For Windows 10, this is the version. For Mac, this is the version here. And this is for Linux version, different Linux version. The versions here for RStudio. So you can just anytime Google it and download and install it. It is completely free. So yeah, one more thing. Before this tutorial, I was thinking that what software to take and what tool to take to discuss the statistical analysis. So we have an idea that it's completely free to use and you don't have to purchase any license. So therefore, we choose this so in the tutorial basically so that you can experience it anytime without any license buy and all these things. So that is why I've chosen this topic in this tutorial so that you can practice it anytime. All right, so console, we've already talked about the console window in RStudio. The bottom left panel is the place where R is waiting for you to tell it what to do. So environment is waiting for your commands. You put the commands, get the output, and it shows the results. So again, I'd like to just put some more commands here. 43 divided by 2, that's giving 21.5. We'll talk about later on about the mean, median, mode, other things. We give the commands and take the outputs in there. Okay, so I'm directly coming into problems here. So as I was insisting that R and RStudio looks complex, and to see that we have so many things here: environment, history, connections, tutorial, files, plots, packages, help you. We're not going into it right now. If I just go into it, then you'll find it so complex and you will see that, oh, what is that? It's looking like to be complex and maybe you would lose interest. But no, you want to develop your interest so that we just put very basic functions, very basic commands, and you can work on it. And then uh, slowly and slowly and slowly, you get into R and RStudio, and then you can just move on to these things like packages and different files environment. But these things you can always talk about later on. But right now, very, very basic So, so moving on to the first question here, we have find the mean of 5, 11, 2, 12, 4, 2. So those are very basic numbers I've taken here, and you have calculators. You can do that. Simply you can do 5 plus 11 plus 2 and so on, divide by 6. You can find out the mean. That's another way. You can use different softwares, but now we're going to use R here to find out the mean of these numbers. The first thing in R is we're not going to directly put the numbers in R and find out the mean. No, the first thing is that define a variable. Define a variable, a set which is known as a vector in R, which is known as a vector in R. So we will define a vector first. The vector means a set containing these numbers, and after that we apply the mean command to find out the average. So I will just go into that. So let us first see here how to define a vector. The vector is, let's suppose I take a variable here x, that's x here, put less than and hyphen sign, and then I put here c. That's a way to define a vector. What are the numbers we have? The numbers is 5, 11, 2. So it's going to be 5, 11, 2, 12, 4, 2. So here we have this 12, 4, 2. I'm again seeing here x, then here symbol is less than hyphen c. That's the notation to define a vector. So first we're defining a vector here, a variable x which contains this data set. That is 5, 11, 2, 12, 4, 2. And I click on enter. It is giving nothing. It seems that it is giving nothing, but you can see here in the environment. Let's talk about a little about environment. Environment is giving the x values. Environment is showing that we have defined x which contain a data set that is 5, 11, 2, 12, 4, and 2. So by doing the enter here, the x is defined as a data set, as a vector which contains 5, 11, 2, 12, 4, 2. Now the purpose is to find out the mean of this numbers. So the command here for mean. So RStudio, if I just type in here mean, RStudio already have this the commands that is built in mean, mean.h, and default and so on. So we just have to work on mean here. Double click on this mean, and the variable is x. The contained data set is contained by the variable x. So I'm just going to put here x and click on enter. Ignore this one, we'll not talk about it. Just 6 here. The mean is coming out to be 6, right? So for this numbers 5, 11, 2, 12, 4, 2, we have mean is coming out to be 6. So let me repeat that. Maybe we'll have uh, more practice in defining this. I'm sorry, the vectors. So let me define by another variable here. Take that. So let's do more practice. This is y less than hyphen the notation. Then we have c always. So less than hyphen c will always come to define a vector. Y, now instead of x, I'm defining now one more variable, that is y, and bracket here we have. Now I'm creating a new data set. Let's create it as 6, then 7, 18, comma is essential, 32, 54, 21, and I click on enter. Now as I click on enter, so I have created a new vector, that is y, that is given by 6, 7, 18, 32, 54, 21. So you can see now, let's talk about more about RStudio. So RStudio, I told you, it's an environment. So environment is showing us the things that we are defining right now. We have defined y to contain this data set, and environment is simultaneously showing us the things here, what we are doing on our console. So with this y here now, we're going to find out the average of y. So we put it as mean and then it is y, enter. The average is coming out to be 23. So I hope it looks like easy to you. So because I've just made you define a very simple numbers here, is containing here, and we define the vector. We put the command mean. After that, we put variable y here or x here, and then we get the output. That's coming out to be 23 and 6. This one we'll not talk about right now because this requires more and more stuff. Let's be very simple. We apply the mean operation, mean command, average, and we get the output. So because the new things, we're going to practice more. Find the mean of the following numbers. The numbers are 17, 12, 11, 5, 5. So now if I again define here x, so I'll do now. Let's again define x here. And it was C, same notation. I put the bracket, define the numbers here, we define the vectors 17, 12. Next we have 11, 5, and 5. I put it enter. You can see here, if I define now x as this vector, now the environment has shown these x values that I have put as latest. The latest x values in the R console which I have put, environment is showing that now. So x is becoming now 17, 12, 11, 5, 5. Now x will not take these values. 5, 11, 2. These values are erased from the environment. The new values which we have defined now is 17, 12, 11, 5, 5. So it is the latest values and environment is showing this. So now if we go for the mean here, we have mean of x. X going to have to be equal to 10. So we go with option B. So I've taken 3 questions for that. The next one, let's do this also. That's again a very simple question. We define the vector again. So you can take any values. I mean, you just take his A here, defined by this. Again C, bracket, value 16, 5, 7, 12. So we have 16, 5, 7, 12. So enter. Now in the environment, A is defined. Put here mean of, we have A. We're going to enter. Value is coming out to be 10. So it's coming out to be here again option B. That's coming out to be 10. So that's a way to find out for very basic numbers. Define the vector, give the command mean, average, and we get the output that is coming out to be, in this case, coming out to be 10 here. So if you look at these things, code, session build, debug, so it looks very complex, but no, we're not going to into this. So we're going to very basic, very, very basic. So it's a mean. More sets of problems we can discuss on to work more on basic statistical things. Next is the median. So find the median of these numbers. So we have the command median in R that we can put and find out the median. So I'm going to first define the vector again for the numbers 4 to 7, 4, 3. Let's find the vector, that's B less than hyphen C. Same notation. 4 to 7, 4, 3. 4, 3. I click on this. B is defined in the environment. I'm going to the command here. So median, double click on this, and here we have it is B. And enter. Look at the value as median is coming out to be 4 for this data set. Next one, we need to find the median for these numbers. So again, we're going to define the vector. It's coming out to be defined by a new name. Let's say it is n less than hyphen c. Same notation. For the numbers 12, 5, 9, 18, 22, 25, and it is 5 here. N is defined in the environment. We find the median. This is N, and we got the median. That is coming out to be 12 here. So the way we find out the median without calculators, we arrange in ascending or descending order and then find the mid value. So it has a straightforward command, median command. You can just give any data values and use the command median, give the variable name of the vector and take the output. That's coming out to be 12. So no need to arrange in ascending or descending order. Of course, we have some functions or commands in R to arrange in ascending or descending order, but we have a directly straightforward commands here to find out for the median. So I just taken one more question for practice for the median, and then we'll move on. The next one is find a median for these numbers. Define a vector. The number 7, 1, 1, 7, 1, 4, 1. Find it, median. This is that. And we get the median that's coming out to be 1 here. So that was the mean and the median in R. How to find out that? The next one is for the mode. The value having the highest frequency. How to do that in R? So surprisingly, we don't have any straightforward function or command to find out the mode. But we have another way how to find out the mode. So I will tell you how to find the mode. So I'm again repeating, we don't have any straightforward command in R to find out the mode. But we have one more way. I'm going to tell you here, and then we can find out the mode accordingly. All right, so the first thing is the method is similar. First, we define the vector. So I will take some more time on the mode because the command will be a little complex. Not that much, but a little complex here for the new user. So I'm going to define here first the vector that is given as, let's say, x. Numbers are 28, 18, 19, this is 18, this is 17. So 28, 18, 19, 18 and 17. I'm defining the vector right now by the name of x. X, I've taken the values here, 28, 18, 19, 18 and 17. So the next step is to find out the mode. Since we don't have any straightforward command to find out the mode in R, another way is we can use a function called library. Maybe you have some kind of basic knowledge about libraries. So because it's a programming language and it's an environment, so it contains a set of libraries. And one of the library, we're going to use that, and in that we use a command to find out the mode. So first we just have to pick up the library here. So I take up the command here, library, and library is mode est. It is mode est. So by the basic way, I can tell you here, library mode est means right now uh, we are commanding environment that we are going to use a library in R, that is mode est. And out of that mode est, because I want to find out the mode, I will use a very basic command to find out the mode that is given as mlv. This command here we have. I shows here mlv is from mode est, right? I double click on this and then I put the variable. that is x, this variable here, 28, 18, 19, 18, 17. I put the variable here, that is x. Next, it's a basic notation. We use method, and then we use equal, and then we type m fv. That's the basic notation we have to find out the mode basically. So the first, we uh, are commanding R to give us access to the library mode est. In this library, we have a command to find out the mode, that is mlv. In mlv, we're using, or the mode of x we need to find out. We're putting x here. The method is mfv. That's the basic notation for this. And click on enter. We'll give the mode here. That's coming out to be 18. You can see here 18 is coming out to be 2 times highest frequency. So we have this coming out to be the mode. So looking out to be a little complex here to find out the mode, but that's an easiest way we have in R to find out the mode. So I'm again repeating. Go to library. First define the vector here. The mode of the numbers you need to find out. Define the vector. Call up the library mode est. It's inbuilt in R. And then use the command mlv. Use the variable x. Method is mfv. I'm not going into it, mfv, because it will become a complex, but just right now use the command here. Method is mfv, and click on enter. You get it as 18. So let's practice it more because it looks like a little bit complex. So uh, we have t, let's define it as 1 comma 1 comma 1, then 2, 3, 4, 5. I'm defining here t now. Right, so library I've already called basically. So let me see that if I again don't call the library mod est, I'll literally use the command here mlv, and then the vector is t, and I put here method equals mfv. Oh yes, I get the mode here that's coming out to be 1. So it was once we just call the library. We have already called it library mode est, so I'm going to call it again, and then we directly use the command mlv for the mode. Use the vector t, and the method is equal to mfv. We get the mode is coming out to be 1 because 1 is coming 3 number of times. The highest frequency we have for the mode, so we get it as equal to 1. So looks complex, but if you practice it, then maybe it looks easy. Let's work on more vectors here to practice it out. We have A defined, so C will be 5099. I'm sorry, my typing speed is not that much good actually, but still I'm just trying to improve my typing speed all the time. 5099 30554 30554, right? So 5099 30554, and data set we have. So this we have defined. Enter. It is defined now. Next, to find out the mode, so use here mlv, the library mode est, a, the vector, method equals we have mfv. We get the mode that is coming out to be 5. So we have to be here option B, that is 5. Next one, I have more practice question. Oh, this one is different here. So let's define the vector again. 5, 6, 3, 9. Let's take it by F. Define this is C. Same notation to define the vector. The data set 5, 6, 3, 9, 5, 6, 3, 9, 0, 4, 1, 2, 7. 2, and 7. Enter. F is defined. To find the mode, use the function command mlv for f method equals amp fv. Enter. Oh, we got all the values here for the mode. Why we get all the values? Because there's not a single digit here having the highest frequency. So for the mode, it is giving us all the values. Having the same frequency, that is 1, because every number here, every digit is coming one time. So we get all the values in the mode. That's coming out of the output for the mode we have. So that was about basic things: mean, median, and mode we have. Next, look on what's in the presentation. Okay, next we have to find out the range. So range is, we know that data set is the highest value, negative, lowest value. Let's go for this. So first, we're going to define a vector here. The numbers are 1, 8, 3. Define this D. Okay, 1, 8, 3, 2, 8, 8. Let's define this. Now I want to find out the range here from the following data. So range is, I want to find out highest value, negative, lowest value. Let me see here. Do we have any command for range in R? Yes, we have a command here. It has the range. It is D. You can enter. What is this? I mean, this is the range here, or we got something else? Okay. So let me define that here. When we give the command range, then it gives two values. One is the lowest value in data set, and second is highest value in data set, right? So it gives two values. One is lowest value, one is the highest value. So after that, if you just find out the range, you do just one more operation here. The highest value, negative lowest value, find out that, so you get the range is 7. Well, that means when we give the command range in R, it is not going to give the final answer. It will give us the lowest value and the highest value, and then we need to just subtract the lowest value from the highest value and find out the range. That is coming out to be 7. Let's see more here. Let me create one more data set. C, and then I put values here: 5, 4, 3, 2, 1. Take some random numbers: 37, 65, 45. I'll define it. I give the command range. Vector is W. So click on enter here. Get the value here. The lowest value is 5. You can see in data set. Lowest value is 5. And the highest value is 87 to find out the range. Alright, so now what you can do here, what is the highest value, and then subtract the lower value. It's coming out to be, get here, 82. And that is coming out to be the range. So here we have one more practice question. Let's work on this. Define the vector here, 5, 3, 6. Going to be 5, 3, 6. Next 5, 3, 9, 4. 9, 4. Click on enter. D is defined to find out the range. With the vector D, which is defined already, Enter. We got the lowest value 3, highest value 9. Find the range 9, -3. We have to be 6. So we have 6 is the required range. Interquartile range here we have Mrs. Jones surveyed the class for the number of letters in their given first name. Data is recorded below. Data is given. What is the interquartile range? So for interquartile range, we need to find out the upper quartile, 75th percentile, then lower quartile, 25th percentile, subtracted to find out the interquartile range. So first let me find out how to find out the basically um, let's say we talk about we're talking about here interquartile range. We're talking about box and whisker plot because we talk about the range, interquartile range, and the median we have. That means we're talking about the box plot here, and we're finding out different values in box plot about the median, interquartile range we have, and then uh, yeah, lower quartile, upper quartile. So let's see that. Let me work on this to how to find out the interquartile range after the range. So what I do, let me just first define this vector here. Or let me take a sample vector to define that. So I define it by S in notation. C should be take some numbers 4, 5, 2, 1, 3, 2, 7, 6, 8, 6, 4, 3. Randomly generating some numbers here. You can enter. We define S. Okay. Now let's say I just want to find out the median, right? So the mid value or in the like we have in the box and whisker plot. For that we have a command that is given as we use it as quantile and then put the vector that is S that we have defined and then we use this command here rotation probes and we give it equal to 0.5 because because we need to find out the mid value. So 0.5 represents mid value, right? 0.5, 1/2. So I'm click on enter. So it's giving out to be 50%. So just like in the box and whisker plot, 50th percentile. 50% means here talking about the percentile. So 50th percentile data it is giving to us. That's coming out to be 37.5. So the notation for that quantile S props equals 0.5. So it is giving the value for 50th percentile. Like we have in the box and whisker plot, we have the median in that. And okay, we're talking about the interquartile range. So for that, we're going to find out the lower quartile and upper quartile, 25th percentile, 75th percentile, take out their difference and find out the interquartile range. So for the same here, this vector which I defined here, let me find out the lower quartile and upper quartile. So with the same command here, quantile, right, and put the vector in this. It's going to have to be S here. Then we use it probes basically. So while using now probes, we need to find out because lower quartile and upper quartile, just put it equal to C. C just like we define the vector. Inside the bracket, we put 0.25, comma 0.75. 0.25 for the lower quartile, 0.75 for the upper quartile. And then just click on it. Let's see here. 25% means 25th percentile. We have the lower quartile, that is 17. 75th percentile, upper quartile, 61. What is the difference here? 61, -17. So that is giving the interquartile range. That's how we work on different attributes of box and whisker plot in R. So I think I'm just going to conclude in a few minutes and so that I just have your doubts also in this. So I'll just take quickly one more data set and work on the interquartile range. So I will define here It's coming out to be, we have 3, 4, 6, 7, and oh, error unexpected. I forgot something. I forgot to put C. C is important, so here we have, that's why I got the error unexpected. So whenever you put that the commands, if you forget something, you do some error, it quickly gives you an output that error unexpected. Okay, come to C here. That will not give error, I hope so. So 3, 4, 6, 7. Oh yeah, now it's not giving the error. Basically, I put C now, and I will go for here quantile, and I put here A, and I use the props equals. We'll have what we use 0.25 for the lower quartile, 0.5 for the median, 0.75. Oh, I think it's giving an error. I think I've used here 0.5 in between. So I've just intentionally do this to show you that we have to do it separately actually. So first let's find the median here. I will just use it here. Quantile. I put the vector is connected to be A. I use props to first find the median here. That is coming out to be props equals 0.5. Oh, it's giving the median. I do it separately. The 50th percentile median is coming out to be 5. And if I quickly do this, quantile, the vector that's coming out to be A, and props equals, put the bracket, 0.25, lower quartile, 0.75, upper quartile. Oh, okay. Oh, yes. I have done some error here, I think. Forget to put C actually. I'm doing it in hurry. Okay. Go a little bit slowly here. Quantile A. It's coming out to be prop equal to, I forgot to put C here. Be 0.25, 0.5, 0.75. Let me just get this as here. I'm giving all three values here. So I just forgot to put C actually. So I was intentionally doing some mistakes. Show you that if we do the mistakes actually, we get some error unexpected. So here we have lower quartile, the median, the upper quartile, right, and range you already know for the box and whisker plot. You find out the interquartile range coming out to be 6.25, negative 3.75. So you'll give the interquartile range here. So that's all we have. So I just made it very basic commands here in R so that you will not get it complex. So let's quickly go through here strength and areas of improvement. So R performs wide variety of functions. It's a very basic function which you have used here. Basic descriptive statistics, mean, median, mode, range, interquartile range. But if you observe it and if you do it on regular basis, you will see that it is really excellent for computing and analysis. It is quick. Then there's one more advantage is there. It is a highly active community. There's a community for R, right? So you can have your doubts with them. You can put your any queries with them, and you can just discuss with yourself, any of your friends that on community you will have. It is designed to make it easy to write scripts. So scripts maybe some way we'll talk about later on. Write scripts in R, but that's another advantage of R. Then areas of improvement here we have. For improvement in R actually, it's a steep learning curve. So it takes time. You see here we have taken so much time in understanding mean, median, mode, interquartile range. If we were on calculator, on other software, it would be really easy. But here it is a steep learning curve. So it takes time to understand R. The packages, some packages we will not talk about, but if you see later on, there are poor quality and speed is slow actually. So bye bye.